Assalamualaikum warahmatullahi wabarakatuh. My name is Adli Artadya Naufal with student number 2206061564. And in this video, I'm going to continue my final exam with by answering the second question, which is student version military application of Spring Math System. We start by answering number one, which is we start with intention. In our pursuit of military application for mass spring system, we are guided by faith and devotion. We seek to honor Allah's teaching by ensuring that our endeavors serve righteousness and uphold ethical standards. With this advancement, we strive to align our work with the principles of compassion, integrity, and divine wisdom. Through this dedication, we trust that our efforts will be a source of blessing and benefit to humanity in accordance with the teaching of Islam. The next step is initial thinking, given the data with like this table. And the trailer, when loaded, remains in a state of equilibrium with a mass of 1,800 kilograms. Its initial displacement is 3 centimeters, equivalent to 0.03 meters. With the question, determine the critical damping value for each shock, which is optimal value to avoid oscillatory motion. And the second question is describe the solution with a certain critical damp value. With the third question, decide which shock is the best for the STT suspension system for the load. The next is idealization. We use this formula where xt is a displacement for its rest position in meters, m is for the mass of the object in kilogram, and beta is the damping constant, and k is the spring constant, and ft is the external force in newtons. To determine the critically damp value for each shock, we need to find the critical damp coefficient. The critical damping coefficient is given by beta c equals to square root of k times m, where k is spring constants and m is the mass of the object. And I will use this Python code to finish this problem. And we start by the instruction. This is the equation: air coaster, cloud riders, and extreme shocks. And this is the code for Python. I'm going to skip this. And this is the data that we get. From this data, we can conclude that extreme shocks is the optimal solution for the STT suspension system during satellite loading, offering near critical damping. They expedite the restoration of equilibrium, reducing oscillations and ensuring robust protection for the satellite during its transportation voyage. And we continue to the second question. We start by intention, as always. In our pursuit of a military application for mass spring system, we are guided by faith and devotion. We seek to honor Allah's teachings by ensuring that our endeavors serve righteousness and uphold ethical standards. With each advancement, we strive to align our work with the principle of compassion, integrity, and divine wisdom. Through this dedication, we trust that our efforts will be a source of blessing and benefit to humanity, in accordance with the teaching of Islam. And next is initial thinking with the same data as before. And the trailer, when loaded, remains in a state of equilibrium with a mass of 1,800 kilograms. In its initial displacement is 3 centimeters, equivalent to 0.03 meters. And with the question, solve the associate non-homogeneous equation and plot the solution. And the second question is find the maximum and minimum displacement. The third question is determine the best shock suspension system for the STT. And the fourth one is solve the associate homogeneous equation, identify both the transient solution and the steady state solution, inverse solution. Plot the solution together to compare, explain the effects of the transient solution in the satellites. And to idealize this, the HMMWV trailering STT with will attain can be modeled by the function ft equals to 200 sine 4t in newtons, where t is in seconds. Assume that x0 equals to 0 and x apostrophe 0 equals to 0. And here's the instruction. Here's how to proceed. Define the differential equation with non-homogeneous terms. Solve this equation individually for each type of shock. Create plots is illustrating the solution. Determine the maximum and minimum displacement. Evaluate the long-term behavior of the system. Determine the most effective shock absorber. For the recommended shock absorber, solve the corresponding homogeneous equation and illustrate both the transient and steady state solution. Here's the Python code. I'm going to skip this. From this Python code, we get this data. And this is the result of the code. And by to answer C, from the data, we get that extreme shocks are the best choice for STT suspension because they offer the best balance between minimizing displacement and preventing oscillation. This balance is crucial for safeguarding the satellite, and the analysis of the provide force function supports this conclusion. To answer B, transient and steady state solution for extreme shocks are analyzed by solving the homogeneous equation. The homogeneous differential equation captures the transient response, showing the system evolution over time. The total solution combines the homogeneous and particular response. And the plot shows A, transient solution, demonstrate rapid decay, indicating swift stabilization of the system. And B, steady state solution, dominates once transient effects fade, showcasing the periodic response induced by external force. And we continue to number 3. We start by, as always, intention. In our pursuit of military application for mass spring system, we are guided by faith and devotion. We seek to honor Allah's teaching by ensuring that our endeavors serve righteousness and uphold ethical standards. With each advancement, we strive to align our work with the principle of compassion, integrity, and divine wisdom. Through this dedication, we trust that our efforts will be a source of blessing and benefits to humanity in accordance with the teaching of Islam. Next, we continue in initial thinking. Given the data with specs is K with equals to 25 Newton per meters with beta 0 Newton meters. Consider the same external force function from part 2, but with the variable frequency, Ft equals to 200 sine 4 omega t, where omega is the degree of roughness of the driving condition. This is the table. And with the question A, solve the initial problem for the function with the time t and frequency parameter omega as variables. Describe the significance of omega and its relation to the speed of the vehicle. And B, for what positive omega is the above solution valid. And C, create an interactive plot of the solution you found in part 3A with respect to the frequency parameter omega for the first 10 minutes of driving. Explain the cause of the change of frequency. Describe undamaging effects the STT might experience while being tailored. And we start idealizing this solution. This is the equation for the undamped equation, and we'll use Python code to solve this problem. And we continue to instruction. This is the Python code. And this is the data that we get. This is data for this is the code for plotting, and this is what we get. As we can see from the data, the parameter omega represent the severity of driving condition linked to vehicle speed, and the higher omega values indicate rougher terrains or higher speed. When omega nears the natural frequency, omega n, resonance occurs. Resonance leads to significant oscillation, potentially damaging the satellite. Specific omega values can cause notable displacement, indicating possible damage. In an undamped system, energy dissipation is absent, leading to unbound oscillation during resonance. Uh, we can continue to question number 4. We start by intention, as always. In our pursuit of a military application for mass spring system, we are guided by faith and devotion. We seek to honor Allah's teachings by ensuring that our endeavors serve righteousness and uphold ethical standards. With each advancement, we strive to align our work with the principle of compassion, integrity, and divine wisdom. Through this dedication, we trust that our efforts will be a source of blessing and benefit to humanity in accordance with the teaching of Islam. Next, we advance to initial thinking. Given the data S equals to 60 seconds, M equals 4,000 kilograms, and K equals to 5,000 Newton per meter, with function of T equals to 300 cos sinus T, and with the question, plot the data of the phenomenon and describe the behavior of the trailer. And the second question, use the data of mathematical to estimate the damping coefficient by minimizing the sum of squared errors, SSE. And C, a suggestion was made that the truck is experiencing resonance or beats its reasonable hypothesis. And the last question is, if they do not turn off the vehicle and the shocks can only extend and compress a length of 0.5 meters, will the structural integrity of the truck be compromised? And this is the idealization with function T equals to 300 cosinus T in newtons. We use Python code to solve this problem. This is the equation for omega n. Omega n equals to square root of k divided by n. And this is the differential equation. We continue to instruction. Create a graph illustrating the displacement data, analyze the trailer's behavior, approximate the damping coefficient by reducing the sum of square errors, SSE, between the data and the model's prediction. Evaluate whether resonance or beats are occurring within the system. Certain whether the truck's structural integrity will be jeopardized under the specified constraint. And this is the Python code. We get this data. And the last question, as always, we start with intention. In our pursuit of military application for mass spring system, we are guided by faith and devotion. We seek to honor Allah's teachings by ensuring that our endeavors serve righteousness and uphold ethical standards. With each advancement, we strive to align our work with the principle of compassion, integrity, and divine wisdom. Through this dedication, we trust that our efforts will be a source of blessing, benefit to humanity, and in accordance with the teaching of Islam. Next one is initial thinking. Given the data like this, the mass is 18,000 kilograms, 1,800 kilograms, sorry, with beta equals to 1,110 newton. And with K, the constant, equals to 170 newton per meter with the function like on this and etc. With the initial condition x 0 equals to 0, derivative of x divided by derivative of t with t equals to 0 equals to 0. And this is the idealization. And this is the function of t, where 2 theta is the time between impulses, and the initial impulse occurs at t. Uh, your job is to complete an analysis of the STT suspension system for a trailer traversing over a rugged terrain. System by each rock as an impulse. This can be done by with a direct delta function of the form, where uh, and to model the terrain with n equals to space rocks, we can express the external force with function t via several impulse function. And this is the differential equation becomes. Next, we go to instruction. The spring mass damper system can be modeled using the following second order differential equation, like this. And to solve this using Laplace transform methods, we start with the Laplace transform of the differential equation. After we Laplace transform, where the xs is the Laplace transform of x function. Rewriting the equation like this, we will solve this differential equation numerically in Python using the impulse train as the forcing function and visual the solution. And this is the Python code. We get this data. And this is the Python code for finding maximum and minimum displacement. And we get this data. And this the C, evaluating structural integrity with different mega values of pi value. And this is the code. And here are some key recommendations based on the findings. Maintain a 3-second interval between impulse to preserve the truck's structural integrity. The second one is ensure the maximum displacement remains below 20 centimeters to avoid compromising structural integrity. Third one is consider reducing speed or enhancing the truck's shock system to mitigate the risk of larger displacement with a 2-second intervals between impulse. And the fourth one is prioritize safety measure to safeguard both the satellite and the trailer during transportation. And uh, after answering all of this question, this is the last part of my video. We'll continue to answer the third question, which is my opinion in Elon Musk's question towards AGI. This will be explained my opinion in the next video. That's all from me from this video. We'll see you in the next video. Wassalamualaikum warahmatullahi wabarakatuh.